Hello guys, welcome again to the channel. In today's tutorial, we're gonna talk about how to create this kind of parametric ceiling structure and animate it using the data channel modifier and the help of OSL shaders. So let's get started. Let me grab our reference images that I found. So basically what we got here is this kind of parametric structure, and we can deconstruct this to three elements. One is a wood cylinders element, and a threads element that's carrying the cylinders, and it's all hanging from this beam structure on the top. And we have this wave happening on their Z position. So we're gonna try to achieve this using the data channel modifier. So first we can start modeling the wood part from a cylinder primitive object. Let's input a radius of 4 and a height of 50 centimeters. Then we can enable edged faces by pressing F4 on the keyboard. Let's remove the height segment, we don't need it in this case. Now I'm gonna apply an array modifier. Keep in mind that you can do the same on previous Max versions, but using the new array modifier will not break the procedural workflow, unlike the old array method. So first thing, let's change this relative offset to total dimension and increase the width and length to 600 centimeters. And the count, I'll set it to 15 for both sides for now. And I'll check the center option to center the model to origin. Now let's add the data channel modifier. So basically, the data channel works by processing mesh data through a series of operations in this operator stack down here to achieve various effects you like. Also, you can feed this processed information back to the modifier stack for more operations to happen on top of it. But just one thing to keep in mind when working with the data channel modifier, that the data flows in the modifier stack from bottom to top, while in the data channel, it flows from top to bottom. So to start, press on Add Operator. A new menu will pop up containing many operators to work with. I'll start by adding a distort operator, which allows us to distort mesh data according to a map input. Now you can see the model became blue. If you look in display rollout, here in the color info section, you will notice that min values are shown blue and max values are shown red. Now the distort operator have no input map, so all values are basically 0. That's why it's showing in blue here. Open the material editor by pressing M on your keyboard and add an OSL noise. Next, let's plug it into the distort map input. Now we can start to see some colors on the viewport, but I think I'll increase the scale of the noise and maybe decrease octaves to 1. Now we'll see clear color values on the model, but nothing is happening because we need to output this information by using one of these output operators. Let's use the vertex output. Well, the model becomes flat. Don't worry, that's because currently it's outputting the distort information into the vertex position on the x-axis, and it's replacing the original values. So first thing, we want to change the output to z-axis and change method to add it on top of the original values. Well, something is happening right now, but it's too small to notice it. To increase our output value, we can use the scale operator. Just drop it after distort and increase the value to something like maybe 150. Now it's a good idea to hit this normalize display option in order to have a better idea of what's going on the viewport. But you can see it deforming according to the noise texture. Well, that's because each vertex is having a unique value from the texture. In order to fix it, we need to have the same values across each element. Doing so is easy. Just use this geoquantize operator and drop it after distort. This basically averages the values on the same element, leaving us with non-distorted cylinders. I'll increase the array count number to 20 so the effect is more obvious. Now our cylinders are moving up on the z-axis according to this noise. So changing its value will affect the shape we got. Feel free guys to experiment to get different results you like. But now we finished the wood part. Let's start setting up our thread model. If you look to the reference, it's basically following the wood part, but the top of it is staying on that wood beam. Doing so is almost the same as what we already did before. I'll copy what we got, change the radius and height of the cylinder, and I'll delete the modifiers on top. And let's copy the array from our previous model and paste it as an instance. So changing one will affect the other. And actually we shouldn't delete the data channel. So I'll also copy it, but paste it as a copy. Now let's make the top part stay fixed. Just to be clear, we're working upside down for now. Instead of moving the cylinders down, we're moving them up. Later we're gonna rotate it 180 degrees to have the right orientation. Okay, now we can use this component space operator. You can read the info on the bottom. So what this operator do is copying the geometry X, Y, or Z position to the stack to be processed. I'm gonna switch it to Z. You can already see that the base is now fixed. So what's happening is this operator value is being multiplied with the stack. Also, we can change this operation to any of these functions over here. We can even replace it and have a multiple inputs and outputs in the same data channel stack. Now I'll set it to replace just to explain what's happening. You can clearly see blue color on the bottom going to red on the top. And it's set here that min value is 0 and max set to 1. So we have 0 value on the bottom vertices and a value of 1 on the top vertices. So basically we're gonna switch the operator back to multiply. So whatever value we had on the bottom will now become 0 and the top is multiplied by 1, so it will remain with the same value. Next, we want to wire the scale value between these two objects. This is very easy. Just right click on the spinner and hit this show in wire dialog. This window will pop up and we're selecting threads now. So we can look in objects for cylinder 01, go to modified object, data channel, then scale, and hit this top arrow to connect it both ways. Finally hit connect. Now they are sharing the same value, which will result of them moving together. So this noise is controlling this setup and it's perfectly fine, but I wanted to move it in a form of a wave, more like the reference image. I will use OSL shaders to create this effect. Go back to the material editor and for starting point, grab UV channel and create a physical material, assign it to our model, and plug UV to color. This is so we can preview what we are doing. Don't forget to switch to high quality on the viewport so we can see the correct maps. Now we can see the UV channel is repeating over elements. But for the wave to work properly, we need the UV to spread across all elements from start to end. Just head to the array, go to UV rollout, and switch mode to clone XYZ. And disable this additive option. You can see that UV is now spreading from 0 value to 1 on the x-axis, also 0 to 1 on the y-axis, and it's shown on the viewport as red and green colors. Now we can start creating the actual wave. Grab a components vector and plug it into distort. Make a copy of it, because this one will only be our output placeholder to the distort. So now making a wave is basically a sine wave. So go to math float and grab a sine node, connect x to sine and plug it to y input. Well, you can't see a wave right now because the wave period is very big. To make it smaller, grab a multiply node and plug it before sine and grab a float value and plug it to second input. We can increase it to have a shorter period, maybe set it to 5 or 10 in this case. Now the wave is working, but we have this issue where the cylinders is going in the negative values. That's the nature of sine waves. It goes from 1 to 0 to -1, but we don't want that in this particular case. To fix it, we can remap our values by using this range remapper node, plug it after sine and change input start to -1. And I don't want it starting from 0, so I'll set output start to 0.1. And to compensate for the wave height, I'll set output end to 2. What we did is we remapped the wave between a value of 0.1 and 2. And I also want to have double wave on both axes, so let's copy all these nodes, switch X with Y and connect it to X input. Well, I don't want them having the same period, so we can plug another value here. But I want to make one relative to the other, so let me grab divide node and plug it between float and this multiply, and divide it by 2 or whatever you like. We're basically done modeling this, but I want to add animation to this by offsetting the waves. We can do it by adding another vector to our original vector. So let me grab add vector and plug it after UV channel. We can use float value as input, and by increasing the number we can offset the wave. And you can totally animate this value, but instead I'll use the frame number map. Now if we move the time slider, you can see it offsetting too fast, so just grab another divide and plug it in between. And maybe divide it by 10. I think it's still too fast. Let's try 30. Maybe 50. Well, I think 50 is good. Now let's finish this by applying some colors. I'll just use a brown material for the wood part and black for the threads. Of course, you can add details to the model by applying edit poly before the array. I'll keep it simple for now, just an inset and extrude on both sides. Then I'll add a base and rotate it 180 degrees. The wave is animated. You can move the time slider if you want. And we can increase the array count if you need so to add more details to the wave. And of course guys, you can apply the same concept we used to achieve similar structures. Maybe like these pictures I got over here, which you can model the same way we did the threads model. And that's it for today guys. Please tell me in the comment section what you think of this modeling method. Leave a like if you found this useful. And subscribe for more 3ds Max tutorials. Thank you guys for watching, and I'll see you in the next video.